Hello, this is Unit 1, Lesson 6 of Math 1 or Algebra 1. It is going to be a second part of a lesson, so that means that we are just building off of it. And it is going to be consecutive integers in perimeter, area, volume, those style of problems, geometry problems. So just as a review, a consecutive integer problem looks somewhat like this. It's going to be x plus 1 plus x plus 2 plus x plus 3, more commonly known as n1, n2, number 1, second number, third number, fourth number, such as that. And the logic behind this problem is that our next number is equal to 1 more than the previous number. So we're adding 1 or we're adding 2. Depends on the situation, but we're repetitively adding 1. So using that same logic, what happens if we're given something like this? Our first value is going to be just any number, and then our second value is going to be 2 times or double the first value, and then our third value is going to be 7 plus, so plus 7 of a value. So using that, you can also make a pattern. Essentially, it's not going to be a repetitive pattern, but it's going to use the same process where you're changing an original number so that it fits the criteria. And that's what we are finding in perimeter and area word problems, in volume word problems, in surface area word problems, all sorts of these styles. So let's look at an example. Find an expression of the perimeter of a rectangle with the length that is 3 times the width. So I went ahead and took some basic notes, but for what we understand, we're finding an expression, which means that we are not looking for a number. So we're looking for something that doesn't have an equal sign, but you can replace a number in it so that it will give as many outcomes as you possibly want, depending on the number that you change. So an expression does not have an equal sign. They don't exist. So we're finding an expression of the perimeter of a rectangle. In case you do not know, the perimeter of a rectangle is 2 times the length plus 2 times the width. And we're given that our length is 3 times the width. So that means that our length is 3 times the width. That's given. But we are not given the width. So we have to build an equation or an expression with these 4 pieces of information that we have. A thing to keep in mind is that variables are for replacing unknown numbers. If you don't know what a number is going to be, or you're trying to solve for a number, you use a variable. So, and as you can see, these descriptions match. So we're going to use width as an unknown number, and we're going to use a variable for it, specifically x. So here I have a drawing of what our equation or our shape looks like. We see that our width is here, and we see that our length is up here. And our length is 3 times the width. That's over here. So keep that in mind. And notice how we have 4 widths. I want you to remember that. So now we're going to replace width with x because it's an unknown number and it's a variable, and x is our variable. When we replace it, we replaced all of our widths with x, and we have 3 times the width. And 3 times the width means 3 times the unknown number. And our unknown number is x, so we're doing 3 times x. And that's why this works. Now we solve for our perimeter. Our perimeter is 2L plus 2W. 3x plus 3x is 6x. 1x plus 1x is 2x. 6x plus 2x is 8x. So the expression that we have for this is equal to 8x, which means that, let's say x is 2, that means the perimeter is 16. If x is 4, the perimeter is 32. It's going to change depending on what the width actually is, but that's something we don't know, so that's why we use x. And you can use this process for all geometry style problems. You can use this for perimeter, you can use this for area, you can use this for surface area, you can use this for volume. You can use this for a multitude number of problems if you don't know something but you're given other information. So let's do some practice problems. Find the expression representing the area of a rectangle given that the length is 4 times the value of the width plus 3. So we are finding an expression again, which means that we are not going to have a number solution. Another thing that we know is that we're finding the area. So our area is length times width because it's a rectangle. So another thing that we know is that our length is 4 times the value of the width plus 3. So this means that we're multiplying 4 to the value of the width plus 3. And because we don't know what the width is, so we can replace our width with our unknown number, which is x, plus 3. So what we understand is that we are multiplying 4 to x plus 3, which looks like that. Then that is our length. And we know that our width is an unknown number, so our width equals x. So if I draw this over to the side over here, our thing would look like x for width and 4 times x plus 3 for our length. Have this simplified, let's rewrite our equation over here before we simplify anything. And now that I think of it. So we're multiplying length and our width. Our length is this number, and then our width is that number. So we multiply everything by x. We start from inside the parentheses, and we do that by multiplying both values. And we do it again. 4x times x, if you did not know, is going to be x squared. Because we're not adding two x's together, rather we are multiplying the two x's. So think of it like 2 times 2 equals 4, 2 squared equals 4. 2 times 2 times 2 equals 8, 2 to the power of 3 equals 8. So that gives us 4x squared plus 12. And that's going to be our expression. And that's going to give us our expression of 4x squared plus 12x, because we're distributing that x to both values, which means that the area of this shape is going to be 4x squared plus 12x. So, which means that if x is 1, our area is going to be 16. If x is 2, our area is going to be 24 plus 16, which is 40. So that's how you do that for this type of problem. It's a little bit tricky because you haven't really been exposed to exponents just yet. But again, it's an expression, it's not a real number, so it means that x can be anything. Lastly, we have find the volume of a rectangular prism where the length is 5. So we're given a value. Our length is equal to 5. And in case you did not know, the volume of a rectangular prism is the length times the width times the height. Our base is 40. We're given more terms here. Our base is 40, and the height is 3 times the width. So we are given 4 pieces of information here. We know our length is 5, our base is 40, our height is 3 times the width. But what we don't know is our width. And how do we find that out? In case you did not know, the base is going to equal the length times the width. So let's just open up a cube here, or a rectangular prism here. So what we know is that our length is 5. So let's make this one the length. No, let's make this one the length. We know that our height is 3 times the width. We don't know our width yet, so we'll just put it as 3w. We'll make that this because this is our height. That means that this number is something that we do not know. But what we do know is that this entire thing has an area of 40. And one of those numbers is 5. So essentially, what we're trying to do is we're going to do 40 equals 5 times our width, w. We divide both sides by 5. We get our width is equal to 8. So our width is 8, which means that our height is 3 times 8, which is 24. So we can replace all of our numbers now, and we are now given all the numbers we need to solve the problem. 5, 24, and 8. So we multiply those 3 things together. 5 times 8 equals 40. 40 times 24, and so you just solve it out, 960. So the volume of this shape is 960. Hopefully that makes sense, and thank you so much for listening to this presentation.